predictability. The milkman, the paper boy, evening TV. Did I get delivered here? Somebody tell me, please. This whole world confusing me. Clouds as mean as you've ever seen. Ain't a bird who knows you're true. Then a little voice inside you whispers, don't sell your dreams so soon. Everywhere you look, there's a heart, a hand to hold on to. Everywhere you look, there's a face of somebody who needs you. Everywhere you look, when you're lost out there and you're all alone, life is waiting to carry you home. Everywhere you look, and everywhere you look.
All right, you guys, so now we're in lesson 1-3, our learning intention. What we'll be able to do is that we're going to use models to multiply fractions.
And so how will you know you're going to be successful? Our success criteria will see a few things for you to understand that you have nailed our concept. First and foremost, using models to multiply fractions such as area models or number lines. Secondly, multiplying numerators and denominators. And lastly, you'll be able to multiply mixed numbers.
Whew. So let's jump into our notes for topic 1-3. We have our essential question of how do you multiply fractions and mixed numbers. Ms. Wilmington is just making a quick note to help us remind ourselves that a fraction is the numerator over a denominator. And then we have a mixed number, which is a whole number with a fraction attached to it. Our numerator is the top number in a fraction, and our denominator is the bottom number of a fraction. Perfect. Now that we know that, we could just jump straight into example number 1 of multiplying fractions. All right. So let's read this. Sorry, I'm going to. Okay, reset, start. All right, so there was 1/4 of a pan of lasagna left, and Tom ate 1/3 of this amount. What fraction of a whole pan of lasagna did he eat? Find 1/3 of 1/4 to solve the problem. So 1/3 of 1/4 is what we're looking for. Okay, so we just want 1/3 of 1/4. How are we going to represent that? Using models, okay? Visual models. So if we look back over to our left, we see that we have steps to multiplying fractions. We're gonna multiply our numerators. So let's set this up as just a multiplication problem from left to right. So if we have 1/3 times 1/4, according to step 1, we're just going to multiply our numerators straight across. So both numerators, 1 times 1. And then we're going to multiply our denominator straight across, 3 times 4. And then we're just going to write our product, which is 1/12. We'll simplify, we'll reduce if we can, if possible. Okay, how do we show 1/12 in a model? How can we solve the same exact problem in a visual form? So our first strategy, we have a bar. So what we're going to do is, Ms. Wilmington, in our word problem, we see that 1/4 popped up first. That is the total, right? So how much was left? There was 1/4. So imagine this bar is what the lasagna was. We're going to split it up into 4s. So this is our part to total, okay? 1/4. 1 is our part, 4 is our total. So Ms. Wilmington is just shading in 1 because we just have one part of this 4 parts of our bar. Okay, so then we have 1/3 that Tom ate. So each of these 4ths, we're now going to split into thirds because Tom ate only 1/3 of this amount. So Ms. Wilmington is just clearly labeling that each of these parts represents 1 out of the 4, right? Now we're going to split each of these 1/4 into 1/3. See how each of these parts represent now 1/3. So now that Ms. Wilmington broke it, each piece of the 4th into thirds, what we're looking for is that we're going to just need 1 part of the total of the 1/3. So we just need to circle just one of the tiny sections because that's how much Tom ate. So now this is going to be our part, our 1 of the total. Now how many pieces do we have total? And when we count, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So now we've just visually checked to make sure that we get the same answer and kind of to explain to ourselves if we need to see it visually, the part that Tom ate of this lasagna, because fractions can get a little confusing, of the total pieces, which is 12. So that's just one strategy. Let's look at our other strategy, which instead of a bar, we have a table. So if we take 1/4 of our lasagna, so now we're going to have our entire piece of our lasagna left, and we're going to split that up into 4ths, and we're going to do that vertically first. So we have 1, 2, 3, 4. These are our 4 parts. Tom only ate 1/3. So we have 3 pieces, right? And he only ate 1 of those 3 pieces. So we cut them up now horizontally into thirds, 1, 2, 3. But Tom only ate 1 little tiny sliver. So just that 1 square shows that that's just the part. And how many now do we have total after we cut this all up? If we count, we have 12. So this is another strategy of showing visually how we can multiply fractions. All right, you guys, let's go into example number 2. We're going to do the example and then we'll talk about what the steps are on the side. This way we're not jumping around too much. So we're multiplying mixed numbers, all right? So we're going to find 7 1/2 multiplied by 2 3/4. In step 1, it says to estimate each mixed number for reasonableness, okay? So in order to do this, we're going to look at 7 1/2 and we're going to estimate around what this number is closest to, right? What makes sense. So 7 1/2, we know it can also be 7.5. If we have 7.5, we know that 5 can round the number up to 8. So let's round 7 1/2 to 8. We'll estimate it. And 2 3/4, you might know that 2 3/4 is 2.75. That sounds like we can round that up to 3. So let's estimate 2 3/4 to 3. So now let's multiply 8 times 3 is 24. Okay, so this is our answer to check to make sure that when we do multiply our mixed numbers, this is going to make sense, right? So it should be close to 24. All right, you guys, so we're going to do our first strategy of our area model. We're going to do that together when we are in class together, all right? So we're just going to, we don't want to confuse anybody, so we just want to jump into our equation strategy. So now let's turn our mixed numbers into improper fractions, right? And an improper fraction is when the numerator is larger than the denominator. Alrighty. So now we're going to refer to our steps on the left to kind of help us with our strategy of the equation way. So we have 7 1/2. If we look over to the left, we're going to change, it kind of will help us change mixed numbers into improper fractions, right? So we're going to convert by our first step, we take our denominator in the fraction part and multiply it by our whole number. So that 2 multiplied by 7. After we find that product, then we'll add our numerator to our product, and then that will be our new numerator, and we keep it over the same denominator. So let's see this in our first fraction and our first mixed number. So we multiply 2 times 7, which is 14. We'll add 14 to 1, and that will give us 15. So we put 15 in our numerator, and we keep our same denominator. So we just keep our same 2 as our denominator. So it should be 15 over 2. Okay, let's do this again just so we don't get too confused. 2 3/4. So first we multiply our denominator by our whole number, which is 8, and we'll add 8 to our numerator, which is 3. So 8 plus 3 is 11. We'll put 11 in our numerator and then keep our same denominator in that mixed number, which is 4. So 11 over 4. Now we can go to our original steps and multiply our numerator straight across and our denominator straight across. So we have 15 times 11, which is 165. And then we have 2 times 4, which is 8. And then we can simplify if possible. Okay, so now that we have an improper fraction, we're going to want to simplify it, right? So our numerator falls inside of our house as the dividend, and our 8 is our divisor. So we're going to divide using long division, and we see that 8 goes into 165 20 times with a remainder of 5. Okay, we write this as a mixed number by putting 20 as our whole number, 5, which was our remainder, is now our numerator, and then 8 will stay our same denominator. So that's how we write that 20 with a remainder of 5 as a mixed number. Okay, so this would be our way to simplify.
Yeah.
All right, let's jump into our first example for our try it. So we are going to do just 2 examples.
Maybe we'll do.
All right, so we're gonna look at quadrant 1. We're looking at example number 2, try it. Number 7 says find 5, 6, multiply by 1/2, and we're gonna use the model to help us solve. So if we take that 1/2, right, so that's what we're going to look at first. So we have a whole table. Ms. Leamington, can you outline the whole table? So we have a whole table, right? So first we're going to split it up into 2, right? Because that's 1/2. So each of these pieces represent a half, right? So we have 1 and then we have 2. Now we're going to find 5, 6 of that 1/2. So now we're going to split these up into 6, right? We're looking at our denominator, and that's going to tell us how many parts we're going to have. Sorry, how many we should have total, how many parts we should have total, right? So each horizontally makes up just 1 6. So they want us to find 5, 6, right? So now we're going to circle 5 of those 1 6. Now, how many squares did we just split this whole image up into total, right? So we have 1, 2, 3, 4, 5 of that 5, right? So we just highlighted the 5. And how many do we have total? So they want us to find 5. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have 12 total. We cannot simplify. So we can check this if you just wanted to multiply then straight across just to make sure that you get the same answer, 5 12s, without using the picture, without using the model. So if you multiply straight across, 5 times 1 is 5, and 6 times 2 is 12. So that is 5 12s. You know that you drew the model right, you know that you shaded it in correctly, okay? So let's look at number 8. We're just here. They don't want us to use a model, so we're just going to multiply straight across. 3/4 times 4/9. 3 times 4, we multiply both numerators, that gets us 12. 4 times 9, straight across, that gets us 36. Is there anything that can go into 12 and 36 evenly? I'm pretty sure. If you've done your multiplication in practice, we know that 12 can actually fit into 36 3 whole times. If we divide 12 on the top and the bottom, then 12 divided by 12 is 1, and 36 divided by 12, we just said, goes in 3 times. So this is how we simplify. We want to find a number that can go into both the top and the bottom evenly. Okay?
And guys, we know that the answer 12/36, right, is the same answer as 1/3. The reason you want to know how to simplify is oftentimes on a test, right, you might get the problem 3/4 times 4/9, and if your choice is A to B and C, right, if you don't see 12/36, guys, you know that that's an indication that you might need to simplify, right? So you want to know how to do both ways, find the simplified and unsimplified version.
Alrighty, perfect. Let's go into our example number 3 on our try it. All right, so let's look at number 17. This is the only one that we're going to do together. So we have 2 3/4, our mixed number, times 8, a whole number. Okay, so let's turn in that mixed number to an improper fraction. So we are going to multiply our denominator by our whole number, so 4 times 2, which is 8, and add that to our numerator, which is 3. So 8 plus 3 is 11, so that's 11/4. And we're going to multiply that by 8. And every whole number is always over 1. So that's a simple tip just to always remember when you see a whole number and you're like, why isn't it in a fraction? I'm multiplying fractions. It's always just going to be over 1. So now we could just multiply straight across now that we turn that whole number into a fraction. 11 times 8 is 88, and 4 times 1 is 4. Now we can simplify by turning this back into a mixed number, because right now it's in an improper fraction. So 4 goes into 88. Well, if we think about how many times 4 goes into 8, 4 goes into 8 twice, right? And we know that it's going to be even, like it's going to be nice and clean. We're not going to have anything left over. So we have 2 8s. So it goes in again twice. So 4 times 22 is 88. So we know that our answer is just 22. Beautiful.